Hey everybody, our final video for 15.1. We're going to wrap it up. This is a condensed list of stuff we talked about in 15.1. So we have conservative vector fields. If G is the gradient of some scalar function phi, we will show in a second that how we can test for that. We showed how to do where that is. We talked about that divergence of F is the dot product of the del operator with F. So div and dot product both start with D. The curl of F is the cross product of the del operator and F. So curl and cross both start with C. We talked about that. Then we looked at what actually the curl of G is. If G is a gradient of another field, the curl is 0. And then the divergence of G, we have del dotted with the gradient of phi gives us the Laplacian del squared phi. If this equals 0, we're looking at harmonic functions. I did not write that down here, but maybe it's worth writing down. If del squared phi equals 0, these are harmonic functions. Okay, so the curl of a gradient is 0. The divergence of a gradient is the Laplacian. That's why I put these two together. They're but the curl and div of the gradient of phi. So let's look at some other combinations. If we do the divergence of the curl, we showed that one equals 0. If you try to do the other way, the curl of the divergence, this is what it looks like. I've got del crossed with the dot product, but recall the dot product makes a scalar. It's no longer a vector. So like this doesn't make sense to cross product the del operator with something that isn't a vector. This doesn't make sense. So curl div F is meaningless. Then let's look at the situation where we do div div and curl curl. The curl of F, if F is not conservative, GF, we show what curl of, well, that was not the same thing. This is the curl of F. I didn't write this out, but it's done in some advanced classes at upper schools. You can see that you get the del operator times the divergence, or you're taking the gradient of this result, because this is a scalar. So we've got a gradient of the scalar minus Laplacian of F. Okay. So we did curl curl, then do div div. We've got the del operator dotted with the divergence, or not. Yeah, we got the del operator dotted with the divergence of F. The divergence of F again is a scalar, so it doesn't make sense to do a dot product with a vector. You can't dot a scalar with a vector. You can multiply a scalar times a vector, but you can't do a dot product. So this is meaningless. And I did point these out because it's when you're doing it on divergence, when you're doing another operation on divergence, it's going to 0 in both cases, or not to 0, it's meaningless in both cases. So doing the curl of the divergence or the divergence of the divergence is meaningless. Okay, some good things to know. We'll be using this stuff later on in the semester. 15.2 is on line integrals. I'll be doing those videos tomorrow. Peace.